Hi everyone, this is your science teacher, educator should be here online. Follow me on my social media, on my Instagram page, on my TikTok, Facebook, Thread, and other social media. And you can also follow my channel. Just write educator should be on my TikTok, educator should be _85. Today we are looking at subject physics year 10 and year 11. Year 10 topic, and there is also WAEC related topics and other NECO. Linear expansivity. When we talk about linear expansivity, we are talking about when you see a materials, let's say for instance a materials like this, when you pour hot water inside these plastic materials, it has ability to expand. In our last elasticity that we did of solid, that it can expand. The same thing when you pour hot water inside a plastic bottle, it can expand due to change in temperature. Now in physics, I have told you, you need your formula to do anything you are doing in physics. Now let's go on. Linear expansivity, we have a formula like this, alpha. Now alpha is just we call it linear straight. Alpha is equal to L2 minus L1 over L1 change in temperature, or you can say extension of this. E is extension in Hooke's. You remember elasticity of solid, extension over length and change in temperature. Now linear expansivity, this is the formula, this is the denoted by alpha. Linear expansivity, L2 means increase in length. That is, when you increase the temperature of like a glass. Now if you measure the round part of a glass, it can give you 10 meters. But if you add water, hot water or hot something to it, that glass can expand. That expansion, a little expansion in that, is what we call increase in length. Then we have L1, our former length. We have theta 2, that is change in theta. This theta stands for change in temperature. You can call it T1, temperature 1, temperature 2. Now that is what we call change in temperature 2 minus take in temperature 1. Now let's look at work example. For instance, now a copper rod whose length at 30 degrees C, that's former, that is the normal room temperature of that is 10 meters. Let's say a copper rod, let me say a plastic bottle whose length at this degree, normal temperature is 10 meters, is heated to 50 degrees. You now increase the temperature. Find the new length of the copper. Take alpha for copper as 0.00017. And you are going to use your formula. Alpha is equal to change in L2 minus L1 over change in L1 change in what? Temperature. What is our L2? That's what we are looking for normally. We are looking for new, find the new length of the copper. Then our alpha has been given us, alpha is 0.00017 Kelvin per Kelvin, is equal to L2 that we are looking for minus L1 10 meter over L1. And I told you change in this one mean change in temperature, that's 50 minus 30 degree. What is our L1? 10. That's 10. Now let's continue. Now from there, we can make our L2 subject of formula to make it very easy. You can make your L2. From here we can say L2 minus L1 is equal to alpha L1 change in theta. Alpha L1 change in theta. Then you cannot go on like this. You can go on like this. L2 is equal to alpha L1 change in temperature. You from the other side, when you what? Collect lightens, this one have a plus L1. Now let's slot in everything that's needed to get our L2. Our alpha is 0.000017 times 10 times change in temperature 20 plus 10. You know, you follow board mass, you do this one first. 0.000017 times 30 plus 10. Our L2 will give us, well, let's use our calculator now. Let's use our calculator. Our L2 will be 0.034 plus 10. L2 will be 10.034 meter. Thank you.